one of mankind's greatest feats. Going into space and landing on the moon. And getting there safely was half the fun. Just ask this guy. Through the 60s, 70s, 80s, and 90s, he was at the forefront of the space program, serving as launch director for 52 space shuttle launches. Talk about pressure on the job. So today, is NASA headed in the right direction? Did they keep secrets during the space race? Did we really even go to the moon? And yes, I had to ask, is the Earth really flat? One-on-one with NASA's Bob Sieck. I am excited about this interview. I've been wanting to talk to this guy for some time. It's a guy who really knows a little bit about space and getting people up into space. Let's begin with where you sort of began with, and if I hope I have this right, the Gemini program?
Right.
64, 65 is when you came along?
Yeah, journeyman engineer. And had spent 3 years in the Air Force military after I graduated from college with the electrical engineering degree. But back then, understand the society was such that technology was just starting to bloom. And using my terms, electrical engineering, well, a chip was still something you carved off a block of wood. Electronics, computers had just been, were just coming to fruition. So electrical engineering was pretty basic stuff. And President Kennedy said, well, we're going to go to the moon. And people like me, young engineers that didn't have much in the way of tools to use or experience, you figure out a way to do it.
So was the Gemini program set up when you began to sort of the precursor to get us to the moon? Let's figure out how to get up there, and then we'll take bodies up there?
Exactly. Mercury proved that, well, okay, a human can exist in space and do some menial tasks, so to speak. And using the physics of the time. It's still high school physics and orbital mechanics. So Gemini said, okay, we've got this concept for Apollo that we're going to launch these spacecraft on a single rocket, and we're going to rendezvous and dock and change orbits and this kind of thing. So, and we're going to have to get out into space, like extravehicular activity, that kind of thing. So prove how to do that in Gemini program. In the meantime, the Apollo program people were developing the rocket and the spacecraft and hoping it all came together. By the time we ended Gemini, we proved that we can do it the way we planned to do it some years earlier, and now we got to get that hardware ready and go fly it.
So I know this is maybe hard to answer in a soundbite, but what did the Gemini program end up? Did we learn from it?
What we learned from Gemini was that our approach to going to the moon was sound. We had a concept that we were well on the way of developing the technology that would be needed. That technology wasn't ready for us, or we were ready to use it at the beginning of Gemini, so we had to prove it. And so we were set up to proceed with the plan of Apollo, which was test this stuff out in Earth orbit and make sure that we've got a good concept for the spacecraft, the rocket is solid and reliable, and use it to go to the moon.
Looking back on that time, were there things that you look back on and go, oh my God, I can't believe we calculated it that way, or we used this, when now you look back and you go, oh my gosh, that was crazy? Or do you look back and say, gosh, we methodically did everything and all in all worked pretty well?
Well, it would be the latter. It probably worked better than we expected it would. A lot of things went wrong with our first concepts that we used this for, because we were doing things for the first time. So there was some stumbling on the ground, and we had some issues in the missions that particularly the extravehicular activity, we didn't get that right the first time, but by the time we got to Gemini 12, we said, okay, we've solved most of the slippery spots, so to speak, and our concept is sound for proceeding to do that on the moon.
And do I understand your first position there, correct me if I'm wrong, that you were sort of in charge of making sure the vital signs of
the astronauts.
Was that during the Gemini program?
That was during Gemini.
Okay.
We had a very crude medical electronic system, if you want to call it electronics, and monitoring system for Mercury. And even at the beginning of Gemini, we weren't sure that the human body was ready for 2 weeks in space of microgravity, exposure to radiation, these kind of things, and that the environmental control systems that we were designing for the spacecraft to keep the astronauts alive and healthy were really going to do that. So in the early programs, particularly Gemini, the astronauts were heavily instrumented, is the best way to put it.
So people understand, little
sensors. Yeah.
Like how many are we talking about?
Well, for Gemini, there was, if just the basics, was more than half a dozen, somewhere
Just
around 8 or 10,
over.
Pasted everywhere.
Right.
And we flew a lot of medical experiments that involved having more sensors, including what's called electroencephalogram brainwaves up here. And today, and of course, we had to bring that technology to fruition as early as we did. When the program started, all we had was a body, and older generation people can relate to this. Sensors going to a recorder, all with wires, and lots more sensors just to get an electrocardiogram. Well, today when you go in a hospital, if you're thinking about the spinoff and the technology we fostered in the space program, you go in a hospital today and you'll see a nurse practitioner, doctor monitoring number of patients remotely. Well, that you can thank the nation's space program for that technology being in place. I think the medical community would have gotten there eventually anyway, but the forcing function that brought that technology on as early as it was we need it now. So you engineers, you get out there with the medical community and figure out a way to get these signals from the astronaut's body through a very crude radio system in the spacecraft and transmit it down to Earth without the benefit of wires.
Right.
Figure it out.
And you guys had one disadvantage now when you look back on it. You guys had no template to play off from. Did you really? I mean, you had no idea each time you guys did something. There was no real path before this that you could look back on.
Well, that's true, and which made it a lot of fun for a journeyman engineer. It was literally start with a clean sheet of paper approach. And think of a concept, and then get smart people together and start using this to go figure out how to do it, build it, and test it. And again, the first time we tried a lot of this stuff, it didn't work. So okay, back to the proverbial drawing board. It was a great environment particularly for an engineer to work in.
Okay, so was there anything during the Gemini program that you guys, just something that was weird that you just didn't realize? I don't know, maybe it was about the human body, or you just, I don't want to call it miscalculated, but you just couldn't have known. I mean, anything that sticks out in your mind?
Well, I think not so much in the rocketry, that sort of thing. We used a proven rocket, an ICBM actually, for Gemini.
Is that really what it is?
Yes, yeah. The Titan II rocket was adapted to use as our launch vehicle of choice because it didn't require much in the way of changes. We didn't want to develop a new rocket. We had enough going to develop the Saturn V at the time, so we used an ICBM and made a few changes to it to accommodate the fact that it was going to launch a spacecraft, and with some connections to the spacecraft, and we human rated it very simply, and it worked fine. We only had one rocket glitch and launch count that we had to scrub one launch. Other than that, it was a very reliable machine. But as far as we didn't get it right. Now, I think the real thing it taught us was in the extravehicular activity, the humans, what do we have to do to set these astronauts up to succeed when they exit the confines of their very confined capsule?
Anything weird that you look back on regarding that?
I would say nothing weird. We expected the unexpected on every mission because we were doing it for the first time. But in terms of weird or far out type stuff, no. In fact, to us it validated, okay, we're doing this right and we're on the right track.
So now let's move forward we start moving into the Apollo missions. Now, what is your position now at this time? Same or different?
It's different. I moved away from the biomedical and the experiments associated with that to being a test team lead engineer for the command service module. And what that means is, so you're running a test with the spacecraft, and you have all the systems, flight control and the radios and the power generation humming together. You're testing the compatibility with the lunar module, another spacecraft, or with the launch vehicle. So the test team engineer, the lead engineer's responsibility is when the procedure doesn't work, and that happened often.
Right.
You get the team of experts together to sort out whether it's really a problem with the hardware or the procedure or the requirements to test it and make the results look like this are unreasonable. It just doesn't work that way. But that was the test team engineer's responsibility. So anytime the spacecraft were powered up, you had to be there and with the experts to sort out what went wrong and to go forward with that. So it was a lot of fun. So essentially, you could say we worked on the problems, the stuff that didn't work, which is exactly what an engineer loves to do.
You made me think about two things there now. When you were coming from the Gemini program and then you switch positions, do you have to apply for it, or do your bosses do they kind of rub their chin and go, he'd be great for this? How does it work?
Well, it's pretty much the latter. The bosses are always looking, at the performance of their team. And management, let me say this about management. It was a great environment to work in because management knew that you young engineers are doing stuff for the first time. And we made a lot of mistakes. And there were screw-ups too, the proverbial screw-ups, but assuming that it wasn't an irresponsible act on the part of the engineers, management's approach was, well, okay, Bobby, let's sit down and talk about this because we're going to the moon, we want to do it right. Is it the training we gave you? Is it the procedures you were given? Is it the tools we made for you? The management approach was, what did we do to not set up this young engineer to succeed? We'll go figure that out, the root cause, I'll call it, of this particular problem, and management will go fix that so these young men can go. And we were all guys mostly.
Right,
back then,
right, back in the day.
Can go figure it out. So it was a great environment to work in. And so, and they're watching, how you react to that. So there is this, you say, yeah, okay, now Bobby, who for the first time he walked into a blockhouse, I was 26 going on 27 years old, giving a go for launch from the biomedical system. Think about the age thing there. But so
wait
now,
a second, Bob, do you know what I was doing at 26? Do you want to know? I wasn't doing that, okay? You don't even want to know.
No, surfing maybe?
No, something like that.
We were allowed to have hobbies.
Little purpose, trust me.
We were allowed to have hobbies, but when you're working around the clock 7 days a week, you don't have much time for the hobbies. But that was pretty much it. So they assessed it and said, okay, he's had a couple of years of experience now, so he can take this job and move on. So yeah.
So would there be a time that they would go, okay, there's a problem, Bob, you need to figure it out? Were there ever times that you went, holy crap, I don't know, I don't understand? I mean, did you scratch your head at times and then start to dig in and try to figure it out?
Well, short answer is yes, because that was your responsibility. That was something that was emphasized. There was no fuzz on it. Said, Bob, you're responsible for this. You can get help fixing out these problems, fixing things, and bring in all the help you need, but you're responsible for it in the long run. You can delegate it you can delegate it to people, you can have help in working it, but we're still going to come to you for the answer, the solution, whatever. And obviously, if you need help, go to management and go get it. So it was responsibility and accountability were really enforced. And when you signed a piece of paper, for instance, said, I reviewed all the data from this test or whatever, and you sign, okay, Bob Sieck, engineer, right. Gemini 6 or whatever, management made you understand that you just gave a go for launch. Just as important as somebody in the control center on launch day, clock ticking minutes or so before launch. It's just as important as the one that they gave.
So it's not like signing a credit card slip where you're like, boom, I'm out of here. You really thought about
it. You really thought about it because
what am I doing?
Yeah, what are you doing? So it was one of these, be sure you're right before you go ahead type of situations, which was responsibility, accountability, discipline was really enforced. In fact, my first boss when I came on board told me, he said, okay, Bob, now you understand that your taxpayers paying your salary and paying for your training and whatever. So you're a national asset, and this is a government mission we're working on. We're going to the moon. It's the commander in chief said that we're going to go do this. So it's the same as I had come out of the military. It's the same as being in the military. You're just not wearing a uniform.
Right.
And that was the mentality and the atmosphere we worked in.
So take me back. That first Apollo mission, what was that mission? What year would that have been?
Well, it was 68 was the first manned Apollo. Now, we flew some unmanned
before that.
Before that.
Okay.
But, Apollo 7 was the first manned, and then it was followed a few short months later, long months for those working on it, by Apollo 8, where we sent the men around the moon.
And do you remember that well?
Oh, yeah, quite well. The Apollo 8 was symptomatic of the whole effort of getting on the moon. I refer to it in my case as a 7-year marathon because you didn't stop. There was always work on something. Gemini, Apollo, even the unmanned missions, we were working all the time. But for Apollo 8, I wouldn't say we were in a hurry, but the pressure was there, and most of it was internal pressure. The boss said we're going to get all this done by the end of the decade, and the end of the decade's coming, so let's get on with it. And so preparing for Apollo 8, it was kind of like, well, the whole program is relying on this mission to be successful. It's the first time we've human rated the Saturn V. It's the first time we've left Earth's atmosphere with any spacecraft, with any people in it. So it's all about this mission. And I recall it was for about 3 months there. I think I could count on one hand the number of days I didn't report to the Space Center.
What kind of hours did you guys work back then? Were they crazy, or was it 9 to 5 like a banker's hour?
No, it was, it wasn't crazy because it was normal to do 12-hour shifts. It was either 7 in the morning till 7 at night, give or take an hour, or the other part of it. And every couple of weeks, you got a day off on a weekend. But even a day off, the phone was there and it rang, and that was the atmosphere for Apollo 8. Yeah, I remember Thanksgiving Day, standing in line behind a number of other workers at a vending machine in the vehicle assembly building, talking about who's going to get the last couple of packages of peanuts.
Would the astronauts come and talk to you before all the missions? Would they chat with you and, hey, what's your thoughts? And would they pick your brain for stuff?
Well, the short answer would be yes. The astronauts were really close, and that was something that we enjoyed as a test team. In fact, the facility, we'll call it the Operations and Checkout Building, that was our administrative home in Apollo, was the same building that the astronauts stayed in when they came down to the Kennedy Space Center. And they did a lot of training at the Kennedy Space Center, not just familiarization with the launch facilities and the spacecraft that they were going to fly in, but there were simulators here the same as they had in Houston, and they were connected to Houston. So they spent a lot of time visiting the control rooms, which were just down the hall from where their quarters were. A lot of social activities in the evening. We would organize what we called beer ball games with them. And but they had a lot of interest. They were out there on the floor most of the time. That building that I referred to is where we did the assembly and the testing of the spacecraft before they got sent out to the vehicle assembly building and connected with the rocket. So that was our administrative home, our work home, and it's where the astronauts stayed. So their presence was there all the time, which was good. It's good to remind the workers that what these missions and flights are all about. It's all about the crew and their mission, number one priority.
So then let's go to the mission when we walked on the moon. What year are we talking?
Well, 69.
69, as we all know. What was your role then at that point?
Well, I was I was still that test team integration engineer, but my primary assignment was Apollo 12 for that one. So for Apollo 11, although I worked in that capacity when the spacecraft was still in the operations and checkout building, once it headed out to the launch pad, there was another lead engineer had the same job that took it through the vehicle assembly building and out at the launch pad, and was the primary guy for the launch count process. So those of us who were not directly involved in the launch count process on it, we could go out to the Space Center and hook in and listen. But we were really advised to stay home and watch that historic event with the thousands, hundreds of thousands of other people that came into Brevard County to go be a spectator also. And I thought, well, I'm going to capitalize on this, because heretofore, all of the missions, I was in the control room with my 8-inch black and white TV set. I couldn't wait to get home to watch the replays on my 18-inch black and white TV set. So I said, no, this is good. I'm going to watch this one with a family, lived in Titusville, so it was good visibility just across the river, less than 10 miles away.
Now, go back to those years. Were you married at this time?
I was, yes.
Yep.
I was married, living in Titusville.
Okay.
I had a 1-year-old daughter and a son that was 6 years old.
So the astronauts, were they just like rock stars? Like, did people look at them and go, oh my goodness, these guys are incredible? And same with you. Did people look at it that way?
Well, people did, but the workers were not so much that way. You know, there's one of the crew, and they would stop what they're doing and whatever, and hi, I'm whatever, and my responsibility is this or this type of thing. And but for the most part, but outside of that, sure, they were rock stars. But we looked at ourselves and we looked at them. We're all part of the same team. They've got the most highly visible job, and obviously they got to accept the most risk in all of this also. But I got a job too, and there's no fuzz on the fact that whatever it is that my assignment is, I'm responsible for that. And I know more than once when the astronauts would go around and talk to people and have the how's it going type of conversation, the people would say, well, okay, you know, whoever, Neil or Buzz or John or whatever, I'm responsible for this, and I can assure you it's going to work.
I can't imagine, though, when you and your wife would go out to dinner or something, and then people found out what you did. People, up to this day, people are probably so intrigued.
Well, they were, outside of the work environment, there was a lot of that, and Apollo 11 specifically. People say, well, how did it feel? You know, well, to be a member of the workforce, it felt just like Apollo 7 and 8 and 9 and 10 and 12 and 13 that came afterwards. In the environment of working, this is what we do. Every mission's important. In fact, you're only as good as the next mission.
Right.
So that's what the focus was. But if you got out of the work environment, the hype, I'll call it, the excitement around Apollo 11 was even higher than it was for the other missions. Yeah.
All right, let's go to the shuttle program now. What was your role there?
Well, in the shuttle program, so I got a head start on at the end of Apollo and Skylab. a couple of missions. I went to work and
Oh, I forgot about Skylab.
well, yeah, Skylab was there. It was this continuation of at least some of the capability we had developed in Shuttle. So I was at the end of Skylab. I went to work in the program office, and I was looked upon as, and there were a number of us, as an
Real quick though, so people that don't know what Skylab ended up coming back, right?
Skylab.
It came back to visit you.
Yes, yeah. We sent a spent, I'll call it Saturn V second stage, put it on orbit,
Right.
and outfitted it as a lab, kind of like the first space station, but it was technology-wise, it was far removed, remedial.
That was a really big deal when it was like.
Well, it was. I said we're gonna have this big cavern up there with some experiments in it, and we're gonna test the ability, get more information on the ability of the body to withstand long duration space flight, and to see if there's other tasks that people can do in that microgravity environment. So we flew 3 crews up there over the period of, I forget, three some years, and we got a lot of good information from it. But that came to an end in the early 70s, and by that time the shuttle had been given the go-ahead to proceed with the desigin of it. So I went from Skylab to the program office.
Well,
in
just so
Shuttle.
people know, because there's a lot of people that don't realize it was a big deal that it was going to come back to Earth.
Oh, yeah.
People were like freaking out that it was
Yes.
going to come in their backyard.
Yeah.
I mean, there was, I lived up in Illinois at that time, and there was so much chatter. People would be like, "Oh man, I don't want to be outside when this thing," and they just didn't understand what's going to happen when it comes. It was a huge thing.
Well, yeah, it was a big piece of space stuff that was eventually going to come back to Earth.
78, 79, somewhere around 77.
Yeah, late 70s.
Yeah.
And but with the technology available then, we had a pretty good idea. Okay, it's going to re-enter here. Here's the major pieces. So they're going to, for the most part, fall in this part of the ocean,
Right.
out near Australia. A few pieces, may make it there, but it's not going to be like a meteor slamming into Earth and with all of the catastrophes that come from that. But and it played out pretty well.
Right.
from
So
that
Discovery.
standpoint.
I'm sorry, I didn't mean to.
Yeah. So we're getting ready to bring a space shuttle down here, or we're actually designing it. So a group of us went to work in the program office that had a lot of experience in assembling rockets, testing rockets, assembling spacecraft, testing spacecraft in the environment where we're going to launch them. So we were put to work to advise the developers, the designers. So, okay, if you want to fly this machine to the advertising brochure of so many flights per year and that kind of thing, and we know as implementers of requirements at the Space Center that you're going to want to test this, inspect that, and you need the benefit of our advice and our experience in doing that kind of thing. So we recommend for this particular system, you put the components here so the technicians can get in there and at the launch pad, and here we're going to need access when the shuttle is vertical as opposed to horizontal. So you got to put some accommodations there. And oh, by the way, why don't you install these boxes over here next to these, because we got to go in this compartment anyway and do this kind of work. So we were trying to help the developers, the designers, to put this stuff where it's maintenance easy. And we had, I would say, limited success in that, because most of the things we suggested either added weight, cost money, or impacted the schedule, the development schedule, and so they weren't, I'll say, readily received. And we said, well, okay, we'll find a way to do it as efficiently as possible, and still try to meet the advertising brochure of so many flights per year and that kind of thing. So I did that for a number of years. I went to the approach and landing tests out in California with Enterprise, which was, of course, the goal of that program was prove that the orbiter could actually be controlled in the lower atmosphere with the amount of energy it had at that time, and the flight control system. And that played out well, and also gave us a leg up, so to speak, on some of the degree of difficulty and complexity we were going to have to deal with the orbiter when finally we got the space-rated version of it down at the Kennedy Space Center. So that's how I started, and so I picked up again a similar responsibility, the test team integration engineer, but specifically it was all of the tests where the shuttle components were put together and tested those connections with the launch pad and the interactions between themselves. So I was in charge of the launch count procedures, the software. Now we had this thing called software, much more use of computers, and all of the software that was going to be used to launch it. And I should mention, so we've been involved, all of us engineers, in the program since the early 60s. Now we come to the early 70s, and we get a breather, so to speak. In the meantime, in the 60s and early 70s, technology has gone into orbit faster than we have. So those of us that had engineering degrees had to go back to school and learn what we had missed when we were too busy trying to stay abreast with technology,
right,
and also working these long hours and long days and long weeks. So we learned what a computer was.
Right.
They didn't exist whenever, and electronics.
Was that overwhelming at the time? Or
well, it
was,
was, yeah, because here we got this new vehicle called the Space Shuttle, and particularly the orbiter, that has real computers in it and digital displays, and back in
what
our
is
time,
what is this?
what is all this stuff? And we had meters and dials and switches, and now things are done with computers, and there's this thing called software. We didn't have many software problems in the Gemini or Mercury programs, and even Apollo, because we didn't have computers that needed software.
Did you grumble and stuff like, oh, this new fangled crap? I miss the old days.
Well, yeah, as those that the hands-on stuff. But on the other hand, we're engineers.
Right.
Said, okay, here's a new tool.
Kind of cool.
Yeah, let's use it to the best of our ability.
So, shuttle program, at least from the outside, seemed like an amazing era. To me, it did. I don't know. It seemed like we were really accomplishing some really cool stuff. What's your thoughts when you look back through that program?
Well, first of all, the complexity of it, particularly, again, for those of us that had heritage in the simpler programs, I'll call them, was mind-boggling. In the past, everything was simple. Spacecraft was simple. The little computer in it, if you want to call it that, was simple. You have more computational power in your pocket right now.
Is that really true? I know, yes, I hear that a lot.
Oh, yeah. And the computers in the spacecraft were basically used to take data from sensors, turn it into information, and then give that to the astronauts, the flight crew, and mission control, and let the flight crew and mission control decide what they're going to do with that information.
It really wasn't operating anything at all.
It was no.
Yeah.
There was when the vehicles docked, it was go up there, okay, and hand, the latches, pull them down by hand and that kind of thing. It was it was a different beast, so to speak. Thousands of things that turned on or off or opened or closed or latched or unlatched, where that number was an order of magnitude less in the previous program. So it was a very complex vehicle, and we quickly said, well, okay, but again, the advertising brochure for the program was this: we're going to make this like an airplane,
right,
an airliner, and
why do you think they wanted to do that? Why did they want to make it? Thinking of the future, possibly.
Thinking of the future,
okay.
This is going to be the space vehicle for any payload. Think about it.
Okay.
You're going to say you got a very expensive payload, and you're going to take it up into orbit and deploy it, and maybe it's going to go further out with its propulsion system. So we'll take your payload up there, whether it's commercial or Department of Defense or NASA or just pure research. This shuttle will do it for you. There's some weight limitations, but it'll do it for you. So think of this. We're taking your payload. We'll get it up on Earth orbit, check it out. If something's going wrong, we'll either fix it with the extravehicular activity, or we'll bring it back to Earth. Where you don't have that opportunity with an expendable rocket. And the space shuttle will do that for you, worlds. This will become the national space transportation system. And we're going to fly it so many times a year, and and in order to do that, we got to operate it like an airplane. Well, it's much more complex than an airplane, and this is the message we tried to give the developers early on. To meet the advertising brochure, you got to put some accommodations in there. And the reality of it sunk in after we flew the first mission and say, well, here's the requirements to test and inspect, and here's all the components involved in that. So the amount of time and resources to do these things takes months instead of days, just because of the design of it. It flew fine. Okay, it was a great flying machine, but from a maintenance standpoint, it was the other end of the spectrum. It requires a lot of very complex and difficult, and a lot of cases hazardous tasks.
Is it a lot to do with reentry too, or takeoff, or all?
It's all, and then there's the wear and the tear. So you look again, Apollo program, the hardware brand new. Had to act new, look new, perform like it was new, and then we retired it. So here's this very complex machine that's got these thousands of components, miles of wiring, and now you've got to prove that it's okay to go fly again. Well, it's all of those components had not had the equivalent of what Detroit does when they test a transmission or a door mechanism or whatever. They test it till it fails. They say, we know exactly how long
this is going to last. Right.
We didn't, with the exception of a few things like the engines and fuel cells in the orbiter and that kind of thing, we hadn't done that on the thousands of components that are out there. Sure, they would do a test on a couple of items and say, yeah, this will work. But then you look at the real hardware. You have to make a decision as an engineer. Is it okay to fly this, whatchamacallit, again or 5 more times before I take it out and replace it with a new one or whatever? And that requires a lot of effort, sustaining engineering, we call it. In the meantime, we're testing and inspecting, and we say, maybe we can fly these things, a fleet of them, a dozen times a year, but it's not going to be a 2-week turnaround of an orbiter every time, and keep putting out bringing in the tanks and the solid rocket boosters also. And then there's a wear and tear on the ground systems, which were mostly Apollo legacy also. So it's getting older also.
Right.
So the degree of difficulty goes up the more frequent you fly.
Right.
That
makes sense. Yeah. I know people want to hear about this. Take me back to the shuttle disaster, the day of. Thoughts on it to this day and looking back?
Well, hindsight, of course, great stuff, right? It's in hindsight, we were again looking at it from way up here. We were pushing hard to get the maximum flight rate out of the shuttles, and still trying to meet all the requirements of due diligence, inspect these things, test these things before you go fly again. We were trying to make, and there was a lot of pressure. Say, well, okay, you guys, you NASA folks,
go figure it out.
Yeah, go figure.
Go in your little room.
But you advertise you're going to fly, so many times a year. So you got this backlog of payloads, customers that are knocking on the door.
Oh, that's true.
Yeah.
Some
of them are Department of Defense, some of them are now commercial, and there's all the other research and government agencies are saying, okay, NASA, get with it type thing. Well, that translates to pressure on the flight team and the team that processes this to do it, but not the shortcut, because it's still all about the crew and the mission. You got to set them up to succeed and safety. But we thought we were pretty good on all of our requirements, that what we call launch commit criteria, that we'd now flown a couple dozen times, and we'd made changes along the way on what's acceptable performance for this system. And but in hindsight, we had not really investigated the environmental effects back in the development phase, actually in the 70s, on a lot of our system, both ground and flight. So we had launch commit criteria requirements that said, well, if you're above freezing or roughly, you're good to go. But it made no reference to what the temperature may have been 12 hours before, 24 hours before, or the exposure for the last 3 days or something like that. What that did to the performance.
And is
of
that really what caused the problem?
Well,
or may have
yes,
led
yes.
to the problem?
Yeah, well, it did. It was the fact that the temperature got so low the night before
Really?
we actually launched.
I see. I didn't know that.
Well, but also it took us back to the 70s, and it said for the design of the solid rocket booster, you folks didn't do enough environmental testing and development testing to get the tolerances right for these 14-foot diameter cylinders that we could put together. If they would fit, we could force them together, then that was acceptable. And the tolerance was this wide. It should have been this wide for this circularity of the boosters. Temperature-wise, had not done enough environmental testing to say, well, you're going to get this much shrinking of these O-rings if it's exposed to this. And the design itself is kind of like a single point failure. So rather than having two clevises, so to speak, around a 14-foot diameter cylinder to come together, we only had that.
How big are these damn O-rings we're talking that we all...
I'm
picturing this. Is it this big?
Well, they're 14 feet in diameter.
Are they?
And yeah.
Oh, okay, good. That makes me feel better.
Yeah, and they're quarter-inch thick.
Okay.
Yeah.
Wow. So
that was it. But it also, we looked at a lot of the other things that could have been a similar trap, so to speak.
Right.
And
but do you think it's possible if the weather hadn't been that cold that
it could? Yeah. Well, that's speculation. But yeah.
Possibly,
it could have. We could have continued. But there was enough data from previous flights where you could tell that the O-rings were getting some impingement, we'll call it, from the exhaust as it traveled this way through the segments, that, hey, we're close to having a bad day, irregardless of temperature. We really need to go fix this design. And but we didn't, because and why? And you can say, why is that? Well, I think it was more that, well, okay, we're still okay. We haven't. It's kind of like saying we haven't had a problem. And in hindsight, we were gambling as opposed to putting together all the factors of what this risk was and making a risk assessment. There's a difference from an engineer's standpoint. There's a difference between accepting a risk and gambling. Okay, and we never put together all the right information to actually measure the risk of proceeding ahead with that design, which in hindsight was flawed.
Right. So where were you when it took off? Where were you sitting? Do you remember?
I was in the control room.
Okay.
At that time, I was not the launch director.
Okay.
I was the director of shuttle operations. So I had the job of worrying about budgets and contracts and running a large organization.
So it's going up. Nobody thinks anything weird of it at the actual launch, right? I mean, we're all watching it, right? Was there anybody like, are you guys going, oh, this isn't good? Or no early indication?
No.
But when it did explode, did you immediately know, oh my God?
I knew it was a bad day.
Because we didn't know when we were watching it on TV. It was like, oh man, did the cameraman lose sight? No, go ahead. Did the cameraman lose sight of it? Is he not following? Did it go over to the left? Because I think that's what a lot of viewers were looking at that moment. Like, oh, maybe it's still there. And then there was this moment, I think everyone. But I was wondering if you guys knew something a little bit earlier.
We were shocked, really.
Yeah.
We had once it had lifted off. We figured, well, okay, all of the immediate energy release stuff is worked just fine, so we should be okay through it. And we knew that once you ignite the solid rocket boosters, they're gonna burn for 2 minutes. You can't put out that flame with any computer or anything like that. But as soon as it did this, we knew, okay, bad day. We have no idea what caused it, but it's a bad day. We're not going to get the crew back. And then alive.
Then where did you go after that?
Do
you walk into a room? Do you guys huddle together? Do you go home?
So the launch team is in total shock. So the test director, we have a contingency plan, and it's okay, launch team. All of your data, logbooks, data, technical data, stays where it is, and the control room will be locked briefly to see if there's any reason to keep the people here. We had to keep a number of people in the control room because they have to do the safing out at the launch pad. There's things they have to close and secure and that kind of stuff remotely. So the team needs to be on station. We have a procedure for that. So we executed that procedure, which doesn't take that much time. And then you send crews into the pad. So then we release the people, the team, and the management team, and those of us that are in, if you're familiar with the structure, so to speak, of the control center. You got a management team in two, we call them glass cages, rooms.
Is that what you call them?
Oh, yeah. where they have visibility on all the data and that sort of thing. And then there's the management rows in the launch control center. That is myself and the launch director and the person in charge of the flow of the orbiter and the center director.
I bet you were glad you weren't launch director that day. Now looking back,
well,
right?
It doesn't. But we're all members of the same team, so whether you're launch director or whatever, it doesn't matter. You felt that
I would have been glad.
And the launch director had been. I knew him well. My successor, we'll call him in this case. In fact, he was back with me in Gemini. He was the lead engineer for the system back in Gemini when it first came on board. Good friends of the family, also. So we got the management team together, and we looked at. They had some videos, some replays of the launch that are captured in another room in the control center. So we went down there first, and they said, "Well, this is the best, a replay of the launch." And all you could tell was something happened at that point. It was just a little bit not much better visibility than we had looking out the window, the control room. So we all convened to another room and had a what do we do now type of discussion. And the program manager at the time was, the one that organized. Okay, here's where we're going to go from here.
But nobody shouted out, "Oh, it's the O-ring! I know it is."
No, nobody had
not a word.
Not a word. Yeah. Nobody had any idea.
Okay.
Nobody. The control room got totally silent because everybody was literally in shock. We were all in shock, and the outcome of the meeting was pretty much. Let's not make any quick decisions today that's going to have a long-term effect. We've got to satisfy the immediate shock and emotional effect that we're under. Our administrator for space flight we had an interim administrator for the agency at the time. So I had to do a press conference, but there was no information to relate to the public, really. Other than, we're sure the crew didn't survive, and we're going to find there will be a presidential investigation, as well as we will set up investigation teams within NASA and the contractors. But in terms of the road to the future, the consensus was, hey, we're all in a state of shock. Let's not make any decisions that important. Just a few hours after launch. We were told as a launch team that Senator Garn and the Vice President were coming down, George H.W. Bush, the older Bush, and we're going to, of course, Reagan was president, and they're going to address the launch team later this evening. Please stay if you can. We understand that if you want to leave, and that was it. And that's all I remember about the day. And other than when I got home, of course, my family was there. My son was away at college, but my wife and daughter were there, and that's when I lost it, so to speak, finally. And the time after that was just it followed the normal post-tragedy events where there's a technical root cause in there somewhere, but there's also other things that have to be looked at when a tragedy of that magnitude occurs.
And not to be morbid on this, but like a car accident, the astronauts would not know would have hit them, would they? With that type of disaster?
Well, probably. I don't know. I could only speculate. The crew was a mix of those that had flown before and those that had not. And in this case, it was mostly had not. So it's hard to say what they thought or felt, although there is indication that there are some safing procedures that they started going through based on some of the information we retrieved.
Which
from
they
the
could
ocean.
indicate they knew something was a little off?
Something was wrong.
Okay.
But how much of that was done and how long after the explosion that occurred, you can only speculate.
Fill us in on where NASA is now. I know during the Obama administration, the Shuttle program pretty much wound up, which was expected to happen.
Right.
And there was a lot of chatter during his presidency. He's ruining NASA. And in fact, there was, because you and I live in Florida, there were a lot of layoffs.
Sure.
This is the end. This is over with. And now there's sort of a vibe that with privatization, things are pretty good.
Yeah. Oh, yeah, for sure. Again, when the Constellation program was canceled nine-ish years ago, and we knew that here comes the end of Shuttle. Well, what are we going to do now? And when we flew the last shuttle flight, everything went down, layoffs, that sort of thing. But thankfully, we had already started this. Let's look to commercialization as an answer to this hiatus, and we'll help foster it. We'll start this competitive process with SpaceX and with Boeing and with others at that time. And get you interested in. And we, NASA, as the government, our long range goal is to turn low Earth orbit stuff, space stuff, over to you all, and NASA's going to go to deep space and do that sort of thing. Which was a transition. We're finally handing the reins, as it were, or the charter over to private industry, which is a long time coming. If you go back to the beginning, everything was Department of Defense. Then okay, NASA, you can do the peaceful exploration of space stuff in low Earth orbit, and we'll have commercial people do satellites and this type of thing for the reasons it's good for commercial. And then it made sense now to say, okay, we're going to we got low Earth orbit. It's not a piece of cake. It's still human space flight, but
right.
But we feel good enough about that to now let commercial people do that. We, NASA, will go to the deep space stuff, and we fostered it with this competitive process and money, lots of money. Regrettably, the budget in the early years, now I'm going back 5-6 years ago, we didn't get the amount of money we wanted through the budget process to give to the commercial people to get them off on a fast track, just like President Kennedy did, say we're going to the moon type thing. But we're going to get you started. We're going to keep you going, and help you with the development of your rockets and your spacecraft, and we're almost there for that. For astronauts, our astronauts in low Earth orbit and the space station, keep on keeping on, and we can go deeper. And the closer we get, the more momentum I think is building to get other commercial entities on board for everything, obviously from tourism to whatever they can do to help their shareholders feel good about investing.
So, do you think Boeing, Elon Musk with SpaceX, do you think we're going to see tourism here soon? Or
Well, I think we will. I think Boeing and SpaceX, they both understand that that the human exploration type of activity and keeping the space station vital and revitalize it if necessary is their number one objective. But they're in parallel with that. They're winding up what they hope to be a more robust, purely for commercial, financial benefit interest. They're doing that also.
But do you think these guys will be the players that will lead us to faraway destinations?
Well, they'll be the ones that will. I think, the real question is what should NASA, as an agent of the taxpayer, a government agency, be doing? Should it be helping us solve earthly problems, or should it be focusing on what else is out there, the real spirit of exploration, or should they do both? History has shown that you seldom get the funding for going both ways,
right.
if that makes sense.
Yeah.
And so I don't know. It's and I think it's a challenge for leadership to decide where NASA should have its first priority once, I think, and it's coming that way soon, once that taking care of low Earth orbit is something that the commercial people are doing, and they're going to do it quite well.
Yeah. Get your thoughts on Mars. I got to give my opinion about this. I think this discussion about we've got to go to Mars, we've got to colonize Mars, we've got to set up maybe some fast food restaurants up there. I don't understand it. It's the most horrible place to live. Obviously, there's no oxygen, there's no trees, there's nothing. Now, maybe sending a rover there like we've done makes sense, but I don't get this whole, we need to have a backup planet because, man, when we screw up Earth, we need to be able to go there and live. Okay, you're never going to live on Mars comfortably like we do on Earth. It isn't going to happen. So are we doing these things because we want to, it's prestigious? Oop, look, we did it. We went to Mars. Or is there something I'm missing about this discussion that I just don't understand?
Well, there's two reasons why maybe we shouldn't have it, make it a permanent home to continue to keep our species going. A smart person once said, only a retarded species keeps all its breeding pairs in the same place. Well, if we have to go there because it's required to keep the species going, then so be it. We're not there yet. But on the other hand, we are using up the Earth at some rate.
But take care of the Earth, Bob. Just let's be nice to the Earth. Let's just be good to that.
I'm with you 100%. And that brings in the other aspect. So we learned so much by our effort to get to the moon in the 60s that improved the quality of life on Earth. A lot of things fell out of that we never envisioned would happen just because President Kennedy says we're going to the moon within a decade.
So you would be in favor of going to Mars? Like, hey, we're going to send 3 astronauts up there and they're going to go live up there for, are you on board on that? I'm
on board with, I would back off a little bit. Personally, I would say let's do an Apollo 8 type of thing.
Okay.
We'll send astronauts up there. They can still collect information from orbit, and so can the spacecraft, and get the benefit of that. It is exploration. We'll learn more than we have from a robot by doing that. We'll learn how to get humans into deep space and back, given that we need to do that. Landing on Mars and trying to increase the population to the rate that
really that doesn't seem possible.
It doesn't seem feasible. I think engineers will figure out a way to do it.
Right.
Because I believe I'm an old engineer, right? So
right.
And I think we can solve anything. I'm not sure that this body was invented or whatever, or developed to be on a planet or have exposure to that much radiation, that much partial gravity. I'm not sure this body was developed to do that. I think it was only developed to exist on this
Good
planet.
You're such. I knew you were a brilliant guy. I just don't understand why other people don't understand that. But so, can the government, if Elon Musk wants to tomorrow send 3 women to Mars, can the government stop you from doing it?
Well, I don't know that they can. All human launches at this point, the rules, the government rules require the FAA to certify
your flight plan, so to speak.
Your flight, yeah.
Yeah.
So I don't know that they got anything in their charter that would say they could say no because you haven't met this requirement, or they could, of course, the requirement is made up by people. They could make the requirement such that you couldn't satisfy it. But I would think the FAA really what they look for is the safety of the citizens here on the planet. If somebody wants to go to, if the rocket meets the standards of launch from this trajectory, if something bad happens, the parts don't fall on Houston or whatever type of thing, then the FAA'd have to say, well, we can't stop you.
That's an interesting thought. And then I can't imagine, isn't it like 6 months, 7 months of travel?
Yeah,
Like,
it's a long trip.
What would you do for 7? I can't stand a 6-hour flight.
I'm with you.
What would you do?
Like I said, that gets back to the fact that I think this body was developed, generated, whatever, given existence to live on this rock that we're on now. I think that's why regardless of your religious background or whatever, I don't think we were generated to live in a place like that.
Right.
We don't have the right organs for it. But that's an engineer's opinion, not a medical opinion. But on the other hand, we're doing a lot of experiments on space station now to see if there's ways we can keep this body intact, so to speak, and functioning for long durations of microgravity and radiation and all the other things that it doesn't like.
You're such a diplomat. Bob's basically saying Mars is a dumb idea. So
Okay, you can go with that.
All right. All right, you're going to love this subject. I can't believe I'm even going to ask you this, because they're going to say you're a part of this. The flat earthers. Do you read about this stuff?
But I don't dwell on it. It's there's people that believe the Earth is flat. There's people that believe we never went to the moon.
Well, flat earthers believe that, like, you guys like you are in on it. Like, you have been covering up that the Earth is more of a dome. I mean, can you wrap your head around this and help me understand? Well, I don't even understand how you'd explain satellites in that if it was set up this way. I don't.
Well, maybe these people never went on an airplane to that got up there 30, 40,000 feet and flew from a destination one direction or another at the same speed. And if you fly to the east, it takes you longer to go 1,000 miles, and if you take off and go west, the Earth is really rotating, and it's. I prove it to them. I don't think I wouldn't waste my time. But but this going to the moon thing, relevant to it's been 50 years. None of these people must have been alive back in the 60s, because if they were, they would have. You would have to believe some of the things you get from the media and the government, that the Russians were trying just as hard to get to the moon than we were. The Russians were ahead of us, technically, and they had really good, not only their technical ability, but they had good intel, so to speak, spy networks and this kind of thing. They knew more about what was going on in the government than we did as average citizens, and we had 500,000 people roughly working on the Apollo program.
Right.
It would be hard to keep a secret from all the people involved in putting that up there with the intelligence that the Russians had, who were trying just as hard to get there as we were. Because if we had faked it, they would have been the first to blow our cover
Right.
and say no. And they would have continued with their program to put men on the moon, rather than canceling it as soon as we got there first.
Right.
But you can try to explain that to somebody, and I know the flat earthers and the conspiracy theories, and I'm sure it goes right over their head. But
one time I started believing them, and you know what was the one thing that kind of threw me off was when they planted the flag, and because it was stiff and
Right.
like wavy,
Yeah.
you know that
Yeah.
view. I was like, yeah, that doesn't make sense.
And
They are in on it, and then I learned later all the problems they had with the flag and trying to
Yeah.
get it to
get it to stay in, yeah, and it would move a little bit. And any movement, there's nothing. There's only a fraction of the gravity here to dampen it out, so it continues to, yeah.
How did they get it stiff like that, though? Do you know?
Well, they had the material first of all
was a hard,
really, yeah, and
I was starting to buy into it though, just a little bit. Yeah, and then there's a movie set somewhere in Yuma, Arizona, and
well, that's the other thing that we didn't have the technology back then to do what you can do now with a computer and videography
and cameras and stuff. Yeah, you're right.
We didn't have it. It didn't exist.
Yeah, and they've always made like weird comments about like the astronauts jumping, and they don't realize what the frame rate was like with cameras
Yes.
back then, and it was
yeah,
it would look weird,
Sure.
some of the stuff,
Yeah.
but they'll point out wires that are hanging or something like that. And anyways,
Love it.
Is it weird for you to hear that stuff when you think of
No.
all the stuff you went through and the struggles and that's insane.
No, I just remember that life is tough. It's tougher if you're stupid.
You like that one? I know. That's good. Well, I guess it makes for good conversation. I think people love. I think people just love conspiracies now, and everything is involved in a conspiracy. And anything when it's tied to the government now, it's got to be.
Oh yeah,
somehow,
you can't believe anything.
Yeah,
Yeah.
we've gotten to a point we can't believe anything we hear. So,
Regrettably.
anything with NASA you'd like to share that we don't know? Maybe the public you've never released, you never thought about or talked about. Is there things that we just don't understand as the outsiders?
I think, a couple aspects about the effort we put in to go to the moon is something that it's all of us that worked on it. And again, there's 500,000 people, and some of them never set foot on Kennedy Space Center or went to Houston Mission Control. For the most part, all these people, and it was because I think a lot because the media helped with this. They felt they were on what they were working on was not just a job, that they were on a mission. They were part of the mission at the time. And at the time, the only thing really that was going on that was good in this country that was, I would call a noble effort, was the effort to put people on the moon and bring them back. Don't forget the best, the ultimate goal, bring them back. And so whether you were working for a company that made meters in New Jersey, or you were down at the Cape working on third shift in the middle of the night, in a building that didn't have windows, and you were in some way doing a test or working on some hardware, hands-on work, that this is more than just a job. We're on a mission here. We're going to do something. What I'm doing is going to result in something good. Yeah, and when it finally happened, and we got the guys up there and got them back. For those brief moments, most of the population of the planet was galvanized and saying, "Hey, something good really happened here."
It brought us together.
And it brought us together.
It united us.
Yeah, and for those 500,000 workers, they were really proud. And they knew what they were doing was important, and it said, yeah, it was important, and I was part of that, and it was a good thing for us, not just me personally, but for us. And I think that gets lost in all the hype and whatever, but it's there. And I extrapolate that to say, so all you youngsters out there, relative to me, everybody's young, that you're trying to decide what trajectory you're going to take on your career path, do something that you enjoy doing and it has a purpose. It's not just about the paycheck and 9 to 5 and go on with your other stuff. I know you got to exist, but choose a trajectory that is rewarding to you, and you have some passion for what you're doing. And I think that's what the space program did back in the 60s, and that's what it ought to do for whatever we're going to do, NASA or whatever we use space for. It ought to have a purpose.
It's really good advice. Let's conclude with something fun. You kind of touched this a little bit. You think we'll discover other forms of life? Maybe, what's your thought?
Well, my thought is, short answer is yes.
Okay.
I'm excited about the new telescopes that are coming on board. And they're going to find more planets that are out there that have some kind of atmosphere. We don't know what kind it is yet. I'm hoping that the technology evolves that we can analyze the atmosphere of those planets. We may find some that has a similar atmosphere as ours. We may find a different atmosphere. We may find some elements that don't exist in our periodic table.
Right. I think that's likely.
That
Yeah.
is. And does that mean there's some form of life out there as we define life? I think I have to believe that there's more life in the galaxies than just us on our planet. I have to believe that.
So people watching, are we the hangar that's over at Kennedy Space Center? Are they hiding anything in there? It's like you walk by, like, you walk through and, oh my God, they got a big blanket over that thing. What the? Tell us now, Bob, and I think you'll sleep better tonight. I really do.
Yeah. No conspiracies. I've been in places over there that you have to be lost to find.
Right.
And I can verify there's nothing like that.
But do you think we've spotted anything? Do you think, like, even naval officers, pilots have seen things that obviously can't be explained? It doesn't mean it's another human form. But on the other hand, do you think things have been spotted and...
There's no explanation?
Well, there's no explanation, but maybe the government is like, this isn't... We don't want to talk about this.
I've been in a lot of government-related... I'll say not places, but I've been able to access government information in a lot of places, and it's not that I'm looking for
I'd be looking. So.
Yeah, and I'm not looking, but I don't. Quite frankly, with all due respect to all the government agencies, we don't have the ability to hide something like that and not let it leak out.
You think
one
guy or one woman would come? Somebody would
eventually. There's got to be a human interaction with it, and somebody would blow the whistle. Yeah.
Bob, awesome. I love it. Thank you for your time.
Enjoyed it. Yeah.
You're an amazing guy, and you have done so much, really, for. It sounds kind of corny, but for humanity, you guys changed.
Yeah.
You all did. You changed our world in a good way. So thanks.
Yeah. Well, and we did, and it didn't feel like work. It was never just a job. It's it was in most cases when we retired, and got the certificate suitable for framing and whatever. We said, hey, it never felt like just a job or real work. I enjoyed it. Whistle when you went to the Space Center and whistle when you left, and I can't wait to hit the ground running tomorrow or tonight.
We're out of here.